So in this video, I'll be covering about the concept of single source shortest path, specifically about the Dijkstra's algorithm. So this strategy, that is greedy approach, where we have various kinds of the problems that can be solved using the greedy approach. That is job sequencing with deadlines, knapsack problem, that is fractional knapsack, and minimum cost spanning tree, that is Prim's algorithm, Kruskal's algorithm to find the minimum cost spanning tree. And in the sequence, we have the single source shortest path, that is starting from any kind of the source vertex. And from this source vertex, what are the various kinds of the vertices that are being present in the graph, and what is the minimum cost that is being associated. That is from source vertex S to A, what is the minimum cost, and from S to B, what is the minimum cost, from S to C, what is the minimum cost, for how many number of vertices that are being present within the given graph. So we can define the problem of a single source shortest path, that is given a certain kind of the directed weighted graph, that is G equal to V comma E, where V indicates the set of the vertices and E indicates the edges. A weighting function cost for the edges of graph G and the source vertex V is being given. And the problem of a single source shortest path is to determine the shortest path or paths from V, that is a source vertex, to all other remaining vertices within the graph G. And it is assumed that the weights are being given in the positive numerical order. And the shortest path between V and some other node V1 is an ordering among a subset of the edges that are being present. The general approach related to the greedy to solve this kind of the problem is to find the shortest paths from V to the remaining vertices, which is used to generate the paths in the non-decreasing order of the edge costs. So I'll be providing an example of the single source shortest path in the next upcoming slides. And the single source shortest path, there are two different algorithms which can be solved for the problem. That is Dijkstra's algorithm and as well as the Bellman-Ford algorithm. So Dijkstra's algorithm is a graph algorithm for finding the shortest path from the source vertex to all other vertices in the given graph. And the time complexity for this SSS, that is single source shortest path, is big of E plus V log V, where E indicates the number of the edges that are present in the graph and V indicates the number of the vertices given in the input graph. And Dijkstra's algorithm is quite faster as compared with the case of Bellman-Ford algorithm, because we can say the time complexity of Dijkstra's is big of E plus V log V, and whereas the time complexity of Bellman-Ford algorithm is big of V into E. That is where V indicates the vertices and E indicates the edges. And coming to the algorithm of the single source shortest path, in this particular video, I'll be covering about the Dijkstra's algorithm. So single source shortest path, as I mentioned, there are two algorithms. There is Dijkstra's algorithm and as well as the Bellman-Ford algorithm. So this slide represents about the Dijkstra's algorithm, where V indicates there is a starting vertex that you have considered, that is a source vertex, and cost, that is cost adjacency matrix, and the distance, it is basically it is also the matrix which is used to find what is the distance from the source vertex to other kind of the vertices within the given graph. And N indicates the number of the vertices. So at the first step, we are initializing the solution set. That is for I equal to 1 to N do S of I equal to false. That is, here we are not considering any kind of the vertices within the case of the solution set. That is S of I equal to false. And distance of I equal to cost of V comma I. And where V indicates the source vertex and I indicates the vertex that you have considered ranging from 1 to N. And make this kind of the source vertex to be equal to true. That is S of V equal to true. And the distance of V is equal to 0. And from the second vertices onwards, that is from the second vertex onwards, determine n minus 1 paths from V. That is, you need to choose U from among those vertices which are not present within the solution set, such that the distance of U is minimum. And there may be several kind of the adjacent vertices that are being connected. That is, for each W, that is, even before this one, you have to make S of U to be equal to true. So what does this true false indicates? That is, S of I equal to false indicates this is the unexplored vertices. And whereas S of U indicates that kind of the vertex is been taken into the solution set. And for each W adjacent to U, what is this W and what is this U and what is this S of W equal to false, that will be provided with an example in your next slide. So you need to update the distance. Like take for example, from the previous iteration, if the distance is equal to of certain kind of the vertex is equal to something like a 20, and with this new adjacent vertices that are being connected, and if you find the updated distance to be equal to something like your 10, then this distance, that is 10, has to be taken into the consideration for the solution set. So that is the purpose where the distance is being updated with the condition, that is, if distance of W is greater than distance of U plus cost of U comma W, then update the distance with the statement distance of W equal to distance of U plus cost of U comma W. So consider a certain directed weighted graph. That is, source vertex is 1. So there are totally 5 vertices within the graph, and there are certain number of the edges, that is, directions are being provided, and that is a purpose where it is a digraph. That is from 1 to 2 with the cost to be equal to 10, and similarly from 2 to 4 with the cost to be equal to 2, and so on. So provided this kind of the weighted directed graph, you need to find single source shortest path distance. That is, from you take any kind of the source vertex, if you take the source vertex to be equal to 1. So from 1, in order to reach to 2, what is the minimum distance, shortest distance? Similarly, from 1 in order to reach to 3, from 1 in order to reach to 4, from 1 in order to reach to 5, what is the shortest distance that we can reach among the various kinds of the paths that are being available. That is what the problem of single source shortest path problem. And this can be solved using the Dijkstra's algorithm based upon the algorithm that has been explained in your previous part. So at the first step, that is based given the algorithm, that is Dijkstra's algorithm, you will be finding what is the shortest distance that we can reach from the source vertex to all other vertices that are present within the graph. So according to this kind of the algorithm, that is I equal to 1 to n do, and there are certain kind of the initializations which are being done. That is, you are making each kind of the vertex, that is S of 1 equal to false, S of 2 equal to false, and so on. That is, in your first loop, that is for I equal to 1 to n do, that is, we have written the statement S of I equal to false. That is, S of I indicates we are starting from the 1 to n. That is, S of 1 equal to false, distance of 1 equal to, because according to the algorithm, distance of I equal to cost of V comma I. So distance of 1, because I equal to 1. So distance of 1 equal to cost of V comma I, and V indicates it is the source vertex. Since according to this kind of the given graph, we have considered the source vertex to be equal to 1. So V value will be equal to 1. And that is the purpose, distance of 1 equal to, that is cost of V indicates 1 and the value of your I indicates 1. The same thing you can also observe within this kind of the steps. That is distance of 1 equal to cost of 1 comma 1. And what is cost of 1 comma 1? That will be equal to 0. Because any vertex that you consider, since the same source vertex, like take for example, from 1 to 1 to reach will be equal to 0. That is distance of I comma I will be equal to 0. And if there is no direct edge that has been associated, then it will be equal to infinity. The same thing that you can also observe with the case of cost adjacency matrix. So within the case of the cost adjacency matrix, you can observe distance from 1 to 2 it is equal to 10, and similar 1 to 4 it is equal to 5, and whereas from 1 to 3 it will be equal to infinity at the initial case, because there is no direct edge that is been connected from 1 to 3 at the initial step. There are only two edges that are being present. That is, we can reach from 1 to 2 with the cost to be equal to 10. We can reach from 1 to 4 with the cost to be equal to 5. And whereas from 1, we cannot directly reach over to the other kind of the vertices. That is, we cannot reach to 3, we cannot reach to 5. And that is the purpose where the distance is being set to infinity. So according to this kind of the algorithm, that is s of 1 equal to false, distance of 1 equal to, that is distance of I equal to cost of v comma I, where I value is equal to 1. So distance of 1 equal to cost of 1 comma 1. And what is the cost of 1 comma 1? That will be equal to 0. And that is how we got distance of 1 is equal to 0. Similarly, this process goes on for your next value of the I. That is s of 2 equal to false. Because during your next iteration, I value becomes 2. So s of 2 equal to false, and distance of 2 equal to cost of v comma I. So since we have assumed v is equal to 1, because we are starting from the source vertex 1. So distance of 2 equal to cost of 1 comma 2, as per the statement which has been given in the algorithm. Distance of I equal to cost of v comma I. So what is this cost of 1 comma 2? Cost of 1 comma 2 is equal to 10, because there is an edge that is been connected from 1 and it is a direct edge. And that is the purpose. Distance of 2 is equal to, that is 10. That is how we got the value, that is 10 for distance of 2. And this process continues for your next values of your I. That is s of 3. S of 3 equal to false. Distance of I. What is the value of your I? That is 3. Distance of 3 is equal to cost of 1 comma 3. So what is cost of 1 comma 3? Since there is no direct edge that is being connected from 1 to 3, there is no direct edge at the initial case. And that is the purpose select. If there is no direct edge, then you can keep it as an infinity. And whereas for the distance, like cost of 1 comma 1, cost of 2 comma 2, cost of 3 comma 3, that is cost of I comma I, it has been set as 0. So here, that is cost of 1 comma 3, distance of 3 is equal to cost of 1 comma 3. So since there is no direct edge that has been connected from 1 to 3, and that is the purpose where it has been kept as an infinity. And it goes on for your next iteration with the value of your I to be equal to 4. So s of 4 is made as false, distance of 4 equal to cost of v comma I, where v indicates 1. That is distance of 4 is equal to cost of 1 comma 4. So cost of 1 comma 4, there is an edge that has been connected from 1 to 4 with the cost to be equal to 5. And the same thing is being represented for distance. That is distance of 4 is equal to 5. And similarly, the next kind of the value of your I, that is s of 5. According to this algorithm, that is s of I equal to false. That is s of I equal to false. Distance of I, that is 5. Distance of 5 is equal to cost of 1 comma 5. And cost of 1 comma 5, since there is no direct edge that has been connected from 1 to 5, there is no direct edge. Observe the direction. That is, here from 5 to 1, there is an edge with the cost to be equal to 7. But there is no connection from 1 to 5 at the initial case. And that is the purpose it has been kept as an infinity in this scenario. And coming to your next iteration. So far, that is to find about what are the values of the distances. That is distance of 1 equal to 0. The same thing that has been represented in the tabular column. That is distance of 1 equal to 0, distance of 2 equal to 0, and distance of 3 is equal to infinity, distance of 4 equal to 5, and so on. Distance of 5 equal to infinity, and distance of 5 is equal to infinity. So far we have done this kind of the iteration. That is for I equal to 1 to n, this kind of your the iteration has been completed. And coming to your next step, the next step that has been involved is S of V is equal to true. S of V. What does this V indicates? That is the source vertex. What is the source vertex that you have considered? That is V equal to 1. So that is the purpose. V is equal to 1. That is S of 1 is equal to true. You have taken this kind of the vertex into the solution set. That is S of 1 equal to true. And according to this step, distance of V is equal to 0. That is distance of V. That is distance of 1. So distance of 1 is equal to 0. After executing this kind of this step, then it goes for the next vertices that has to be taken into the consideration. That is for num equal to 2 to n minus 1 2. That is when you consider the value of the num is equal to 2, then according to this step, that is choose u from among those vertices not in S, such that distance of u is minimum. What does this indicates? Out of all these values, what is the minimum? You have to exclude the value 0 and infinity. So what is the minimum? So minimum is equal to 5. So choose u, that is vertex, such that the distance is minimum. That is, if you consider about this kind of the distance matrix, you have to choose the vertex which is the minimum. That is, here you can observe 0, 10, infinity, 5 and similarly infinity. As I mentioned, you have to exclude 0 and similarly infinity. The other values are 10 and similarly 5. So 5 will be the minimum. So consider this kind of the vertex and store it as an u value. That is u equal to 4. And according to the algorithm, that is S of u equal to true. So S of u equal to true. What is the value of your u? That is 4. So S of 4 is equal to true. So you have taken that kind of the vertex into the solution set. So after this one, then it goes for the next kind of the steps. So the next steps that is been involved is for each w adjacent to u with S of w equal to false. What does this indicates? You need to explore the unexplored vertices. For each w adjacent to u, that is from 4. If you consider this kind of the vertex from 4, what are the various kinds of the vertices that we can reach? That is the edges. So from 4, there is an edge that has been connected to 2. Of course, it should be here, 2, vertex 2 should be present. So from 4, there is an edge to 2. And from 4, we can go to 3. And from 4, we can connect the vertex that is 5. The same thing is been represented. Those are the adjacent vertices. So what does this W indicates? W indicates from U, what are the various edges that we can connect? According to this kind of the graph, from 4 we can reach to 2, from 4 we can reach to 3, and from 4 we can reach to 5. These values, these vertices, that is 2, 3, and 5 becomes the respective values of the W, that is adjacent vertices. So the same thing is being represented. From 4 we can reach to 2, from 4 we can reach to 3, and from 4 we can reach to 5. And what are the edge cost that has been associated? That is from 4 in order to reach to 2, the edge cost is equal to 3. Similarly, from 4 to reach to 3, here you can observe from 4 to reach to 3, the edge cost is equal to 9. The same thing is being represented 9. From 4 we can reach to 5 with the edge cost to be equal to 2. And you should also check each kind of the W is equal to false or not, because according to this kind of the condition, that is S of W is equal to false, this condition should also be true. So since as of now we have explored, and similarly 1, that is S of 1 is equal to true, and similarly S of true equal to true. So according to this case, S of 2 is equal to false. It is the true condition. So far we have considered S of 1 is equal to true and S of 4 is equal to true. Only these two vertices are being taken into the consideration of the solution set. So S of 2 will be equal to false, because at the initial step we have made all the kinds of the S of 1, S of 2, S of 3, S of 4, and similarly S of 5 to be equal to false. And then we have updated S of 1 to be equal to true and S of 4 to be equal to true. Whereas the remaining S of 2, 3, 5, it will be equal to false. So s of 2 equal to false, it is a true condition. S of 3 equal to false, it is a true condition. And s of 5 is equal to false, it is the true condition. And coming to the next step, that is if distance of w, that is take each kind of your the w values. That is when you take w equal to 2, whether the distance is been updated or not, that we are considering. So w equal to 2, and according to this step, if distance of w is greater than distance of u plus cost of u comma w. So what is this w that we have considered? The w that we have considered so far is nothing but it is equal to, that is 2. So we are considering the first w of your u, that is 2. So take the value of your the w is equal to 2 and check. That is distance of w is greater than distance of u plus cost of u comma w, whether it is a true condition or not. So what is this distance of w? That is distance of 2. According to this case, distance of 2 is equal to 10. You can observe distance of 2 is equal to 10. The same thing, 10 is been represented. And the next one is greater than distance of u plus cost of u comma w. So what is the value of u? U indicates the value to be equal to 4. So distance of 4. So what is the distance of 4? That is 5. 5 is been indicated. Plus cost of u comma w. So u value is equal to 4 and similarly w value is equal to 2. Cost of 4 comma 2, that will be equal to 3. So is 10 greater than 5 plus 3. So 10 is greater than 8. It is the true condition. If this condition is a true condition, then it indicates there is an update in the distance. And according to this statement, that is distance of w equal to distance of u plus cost of u comma w. That is, you are updating the distance of 2 with the minimum value, that is 8. So distance of 2 is being updated with the value to be equal to 2. So this process goes on for how many number of adjacent vertices that are being present. That is, here you should also take into the consideration of the next adjacent vertex from 4, that is from u, that is 3. So from 3, that is adjacent vertex 3, find out whether there is a distance update or not, given certain kind of the condition, that is distance of w greater than distance of u plus cost of u comma w. So based upon this condition with respective values, that is w is equal to 3, that is distance of 3 is greater than distance of u is equal to 4, and cost of u value is equal to 4, and w value is equal to 3. So what is this distance of 3? Distance of 3 is equal to infinity. According to the values of the distance of 3 is equal to infinity. Is infinity greater than, that is the value of the distance of u, that is distance of 4. What is distance of 4? That is 5. Distance of 4 will be equal to 5 plus cost of u comma w. What is cost of u comma w? That is cost of 4 comma 3. What is 4 to 3? So cost of 4 to 3 is equal to 9. So here we got distance of u equal to 5 plus cost of u comma w, cost of 4 to 9, I mean 4 to 3, that is equal to 9. So 5 plus 9, that will be equal to 14. The same thing is being represented here. So is infinity greater than 14? So here in this case, that is distance of 3 is being updated with the value to be equal to, that is 14. So now distance of 3, previously it was infinity, now it is being updated with the value to be equal to 14. So that is how this kind of the value of the w is being taken into the consideration. And there is also one more w, that is 5. So take w equal to 5. So when you take the w value to be equal to 5, you'll be checking once again the condition, if distance of w. So if distance of w is greater than distance of u plus cost of u comma w. So what is the value of the w? That is 5. So distance of 5 is greater than distance of u, because u value is equal to 4, and cost of u comma w. U value is equal to 4 because we have started from the vertex u comma w. What is the value of the w? That is 5. So a distance of 5. What is the distance of 5? That is infinity. So is infinity greater than distance of 4? What is distance of 4? That is 5 plus cost of 4 to 5. So from 4 we can reach to 5 with the edge cost to be equal to 2. That is 5 plus 2, that is 7. So infinity greater than 7, it is a true condition, and that is what we are updating, distance of 5 to be equal to 7. Previously it was infinity, now it has been updated with the cost to be equal to, that is 7. So this is how for the value of your the num equal to 2, we have updated these kinds of your the values. So what values are being updated in your next iteration? That is, in your next iteration, you can observe what values are being updated. That is, distance of 2 is being updated, and similarly distance of 3 is being updated, and as well as distance of 5 is being updated. So this is how the new updated values are being included within your distance matrix. That is, distance of 1 equal to 0, it is unchanged, and distance of 2 is equal to 8 because it has been updated according to this iteration. That is, distance of 2 is equal to 8. If it is lesser, then you have to include. If it is greater, then whichever is a less one, that has to be included within your distance matrix. And within the case of the distance of 3, previously it was infinity. Now we have updated the distance of 3 to be equal to 14. So that is to be included in your next iteration. Similarly, distance of 4, it is unchanged. The same thing 5. And similarly, distance of 5 is been updated with the value to be equal to 7 when you consider from the previous. So previously distance of 5 is equal to infinity. Now it has been updated with the value to be equal to 7. This is for when the num value is equal to 2. And this process has to be done for how many number of vertices that are being present. So the next iteration, in your next iteration, that is num value will be equal to 3. So after the iteration of your the 2 is been completed, that is the next iteration, that is num value will be equal to 3. So num value is equal to 3, and the process continues. That is, here you'll be choosing u from among those vertices not in S such that distance of u is minimum. That is, from these values, what is the minimum? As I've explained, you should not take into the consideration of 0 or infinity, and the other values, whichever is the minimum. So 8, 14, 5, 7. And similarly, since we have already, in this case, we have made S of 1 equal to true. That is, S of 1 is equal to true. And in the previous step, when the value of the num is equal to 2, that is, S of 4 is made to be equal to true. And in this case, that is from what is the remaining minimum thing, because we have already taken 4. So we have already taken the vertex 4. So that is not the minimum in your next iteration. And the next minimum will be equal to, that is 7. And what is its respect to vertex? That is 5. That is u. So u is equal to 5. And according to the step, that is S of 5 is to be made to be equal to true. So S of 5, what is this? S of 5 is been made to be equal to true. And the next step, therefore, that is for each w, w adjacent from u. So what happens? That is u value. So what is this u value according to this step? When the value of the num is equal to 3, that is u value will be equal to 5. The same thing that we have considered. And from 5, what will be the values of the w's? That is, from 5 we can reach to 3, and from 5 we can reach to 1. So there are two values of the w. That is, 5 to 1 we can reach, and similarly 5 to 3 we can reach. So 5 to 3 we can reach, and similarly 5 to 1 we can reach. So here 5 to 1 with the cost to be equal to 7, 5 to 3 with the cost to be equal to 6. Check whether S of w is equal to false. How about the value of the w in this scenario? That is w equal to 1. So already we have considered. In your solution set, that is S of 1 is been taken as true, and similarly S of 4 is been made as true. And you are checking whether S of w is equal to false. What is the value of the w? That is 1. S of 1 equal to false, it is false condition. It is the true condition. So this you should not take into the consideration for your next steps to be executed. So what is the next kind of here the W value? That is 5 to 3. We can reach from 5 to 3 with the cost to be equal to 6, and you have to check whether S of W is equal to false or not. So what is a W value? That is 3. S of W is equal to false. It is the true condition, because so far 1 is true and similarly 4 is true. And when you check S of 3 equal to false, it is the true condition. If it is a true condition, then you have to check whether that kind of here the distance is being updated or not. So here we are considering only the W value to be equal to 3. Why? The same thing which I have explained. Because this condition is the false condition. If it is a false condition, then you don't have to take this kind of here the W value. That is W equal to 1. So when the value of here the W is equal to 3, find the same thing. That is a distance of W. That is W value is equal to 3. Distance of 3. What is the distance of 3 according to this case? That is 14. So distance of 3 is equal to 14. Is greater than distance of U. What is the value of your the U? That is 5. That is distance of 5. What is distance of 5 according to this matrix? That is 7. So 7 plus cost of U comma W. So what is the value of your U? That is 5. So cost of 5 comma W. What is the value of your the W? That is 3. So cost of 5 comma 3. So what is the cost from 5 to 3 in the given input itself, graph itself? That is 6. So 7 plus 6 is 14 greater than 7 plus 6, that is 13. It is the true condition. If it is a true condition, then update the distance. What is the distance? That is distance of 3. What is the value of the W? W value is equal to 3. So W value is equal to 3. So distance of 3. So distance of 3 is equal to distance of U plus cost of U comma W. That is 13. 7 plus 6, that will be equal to 13. Update the same thing. That is distance of 3. Previously, it was 14. Now, in your next iteration, if it is minimum, then include. If it is not minimum, you don't have to include that kind of the value into the distance matrix. So W value is equal to 3. Distance of 3 equal to 13. So the new value of your the this kind of your the distance of 3 is being updated with the value to be equal to, that is 13. And this is for your iteration, that is num value is equal to 3. So during your next iteration, the values are being updated. The values are, distance of 1, the same thing, it is unchanged. 2 is unchanged. 3, it is being updated with the value that is 13. And whereas 4, 5, there is no, we don't have to take that values into the consideration, because it is already the shortest distance. And the value of your the num increases by 1. That is num value is equal to 4. So far, what is the vertex that you have considered? That is S of from the previous step. So you have made S of 5 to be equal to true from your previous step. And the value of your the num will be incremented by 1. That is num value is equal to 4. And from this kind of your the value, that is during this kind of your the iteration, you need to check the U value and similar W values and so on. So here from these values, so this should not be taken into the consideration, this should not be taken into the consideration. And distance of between 8 and 13, what is the minimum? That is 8 is the minimum. So, and what is its respect to vertex? The vertex will be equal to 2. So that is the value of U equal to 2. And make this kind of your the S of 2 to be equal to true. So in your solution set, you have made S of 2 to be equal to true. S of 2 to be equal to true. And find what are the various kinds of your the adjacent vertices that are being present. The adjacent vertices from 2. That is from at the back, we have the vertex 2. From 2, we can reach to 3. And from 2, we can reach to 4 with respect to edge cost. So here 2 to 3 with the edge cost to be equal to 1. 5 to, okay, this should not be present. So 2 to 3 only, because U value is equal to 2. And the next scenario. So from, you need to check whether S of W is equal to false. So S of 3 is equal to false, because we have not explored that kind of the vertex. So here W value will be equal to 3. So W value will be equal to 3. And similarly, when the value of here the W is equal to 3, the new values which are being included within the case of your the values, that is you made s of 3 to be equal to true. So from the previous step, that is s of 3 is equal to false, it is the true condition, and the value of your the w will be equal to 9. So the new updated value of your the distance of 3 will be equal to 9 based upon the condition that has been included. That is distance of w is greater than distance of u plus cost of u comma w. If it is a true condition, then update the distance. That is distance of w is equal to distance of u plus cost of u comma w, and that is what we get. Distance of 3 is equal to 9, and the same thing is been included in this kind of your the values. So this process goes on. That is, you have made s of 3 to be equal to true, and similarly, so far all the vertices, that is 1, 2, 3, 4, 5 are being explored. So within your solution set, you have started from the source vertex, that is 1, and similarly you have taken the next kind of your the edge with the minimum cost, that is s of that is 1 comma 4, and in the next scenario we have taken s of 5 to be equal to true, so 1, and similarly 1 4, and similarly 1 4 5. In the next scenario, in the next iteration, that is s of 2 is being made as true, that is s of 2 is made as the true, that is 1 4 5 2, and in the next iteration, that is s of 3 is made as true. So that is the purpose where within your solution set, that kind of your the vertex is being taken into the consideration, that is 1 4 5 2 3. And what is the minimum distance? What does this actually the single source shortest path indicates? That is from 1, what is the shortest distance to reach to 2? From 1, what is the shortest distance to reach to 3? For all the other vertices which are present in the graph. 1 comma 4, what is the shortest distance? 1 comma 5, what is the shortest distance? Because we are totally having 5 vertices, this is the kind of your the from 1 to 2. So 1 to 2, the distance, minimum distance is equal to 8, and from 1 to 3, the shortest distance with the cost to be equal to 9, and from 1 to 4, the shortest distance equal to 5, and from 1 to 5, the shortest distance is equal to 7. This is what the solution, and you can also draw the same kind of your the diagram, that is 1 to 2 with the cost to be equal to 8, and similarly from 1 to, there is no direct cost that is been associated from 1, so 1 to 2 to 3. Actually, according to this case, 1 comma 4 has to be taken into the first kind of your the scenario, that is from 1 we can reach to 4 with the minimum shortest distance to be equal to 5, and from 4 we can reach to 5 with the distance to be equal to 2, totally 7. The same thing you can also observe in this kind of your the distance matrix. What does this kind of your the distance matrix indicates? From 1 you not reach to 5, the shortest distance is equal to 7. The value that is been indicated is 7. Here you can observe from 1 you not reach to 5, that is through 4, 5 plus 2, that will be equal to 7. And the next one, that is 5 here 4 to 2. So here, if you consider about your the 4, we can reach to other kind of your the vertex, that is 2. That is what is the cost distance of 2? Distance of 2 is equal to 8. That is from 1 through 4 we can reach to 2 with the distance to be equal to, 2 to 4 with the distance to be equal to 3, and the total distance will be equal to 8. That is 5 plus 3, that will be equal to 8. And the same thing you can also observe, the shortest distance to reach to 2 is 8. And similarly, the next vertex, that is 3. That is how to reach to this kind of your the 3. What is the minimum distance? The minimum distance will be equal to 9. That is from 1 to 4 to 3. 1 to 4 to 3. That is 4 to 3 edge cost at the background. I don't have this one. So here you can observe the shortest distance to reach to 3 will be equal to 3 will be equal to 9. How did you get this kind of your the 9? So here you can observe from 1 to 2 to 3 with the cost to be equal to, that is 9 can be observed. So if you look at the given input graph, if you look at the given input graph, here you can observe the shortest distance to reach to the respective vertex will be equal to, that is 9. How did you get this kind of here, the 9 value? That is from not reach to 3. That is not reach to 3. That is from 1 to 4 to 3. The cost is 14. That is not the solution. 1 to 4 to 2 to 3. What is the cost? That is 5 plus 3 plus 1. That is 9. So the path is 1, 4, 2, 3. With the cost to be equal to, that is 9. That is 5 plus 3 plus 1. That is how you can get the values. That is distance of 3 is equal to 9. So here you can observe distance of 3 is equal to 9. So this is how we can solve the problem of a single source shortest path using the Dijkstra's algorithm. And the other method where you can solve the problem of, the same Dijkstra's algorithm, but in the different kind of the strategy. That is, consider the same kind of the input given graph, and you can make some kind of the columns indicating like what is the iteration and what is the solution set that you have considered. That is, what are the vertices that you have considered in your solution set, and what is the vertex that you have selected, and the vertices according to the input graph. There are totally, that is n equal to 5. 5 vertices are being present. That is vertex 1, 2, 3, 4, and similarly vertex 5. So during your initial step, nothing is being selected and you are finding the distance matrix. That is cost of 1 comma 1 equal to 0, cost of 1 comma 2. That is 1 to 2, there is an edge that has been associated. The cost is equal to 10. And 1 to 3, since there is no direct edge from 1 to reach to 3, there is no direct edge. And that is the purpose infinity has been kept. And from 1, we can reach to 4 with the cost to be equal to 5. The same thing is been represented. And from 1, there is no direct edge that has been connected to 5. From 1 to 5. If there is no edge, then infinity has to be kept. So that is the purpose where during your initial iteration, the values of the distance matrix will be equal to, that is 0, 10, infinity, 5, infinity. And in your next iteration, so choose the minimum. As I explained, discard the 0 and similarly infinities and find out the other values, and whichever is the minimum, that vertex has to be selected. So if you consider this one, you should not take into the consideration of your 0, infinity should not be taken, and the remaining values are 10 and 5. So 5 is the minimum or the minimum value. So that kind of the vertex is to be taken into the solution set. That is, and your next iteration, since you have started from the source vertex 1, the next vertex that you have selected is equal to 4. And similarly, from 1 through 4, can we reach to 2? We can reach to 2. So from 1 through 4, we can reach to 2. What is the cost? Here, this is the cost is 2, and 4 to 2, the cost is equal to 3. That is 5 plus 3, that will be equal to 8. So compare with the previous value. Previous value is equal to 10. Now, the latest value that you got is 8. If it is minimum, then include within the case of the solution set. That is, distance of 2 is equal to 8. In the similar fashion, from 1 through 4, from 1 through 4, can we reach to 3? Yes, we can reach to 3. From 1 through 4, we can reach to 3. And what is the cost? That is 4 to 3 with the cost to be equal to 9. So what is the entire cost? That is 5 plus 9, that will be equal to 14. So how about the previous value of the distance of 3? Previous value of the distance of 3 is equal to infinity. And what is the distance which has been updated? That is 14. If it is minimum, then include. So 14 is been included. So distance of 3 will be equal to 14. And you should not take 4 because it is already been in the vertex selected state. And distance of 5. That is, from 1 through 4, can we reach to 5? Yes, we can reach to 5. And what is the edge cost from 4 to 5? The edge cost is equal to 2. So what is the total distance? 5 plus 2, that will be equal to 7. So check the previous value of the distance of 5. So previous value of the distance of I is equal to infinity. And what is the latest value that you have considered? That is 7. So 7 is minimum. So you have to take this kind of the minimum value, that is 7. So you should not take into the consideration of the 0, and similarly you should not take this kind of the value because it is already in your, we have explored this kind of the vertex. So between the remaining values, that is 8, 14 and 7, what is the minimum? Minimum is equal to 7. So what is the vertex that you have to select? The vertex that you have to select is 5. So in your next iteration, already we have considered the 4 vertex. That is what we have written. That is 1, 4. And in the previous step, we have considered the vertex 5. So vertex 5 is been selected. And find out. How to find out? That is from 1. That is from 1 through 4 and as well as 5 can we reach to other kind of the vertices. That is from the directions I'm including. What is the next vertex? That is 2. So from 1 through 4 and 5, can we reach to 2? We cannot reach to 2. Of course, we can reach from 1 to 4 to 2. What is the cost that is been associated? That is 5 and similarly 3. We cannot reach from 1 to 4 to 5 to 2. And that is the purpose where the distance is not been updated. The same value, that is 8. And take the next one, that is from 1. So from 1 through 4 through 5. Why? Because 1, 4 and the vertex that you have selected is 5. So from 1 through 4 and 5, can we reach to 3? Yes, we can reach to 3. We can reach to 3. And what is the total cost? That is 4 to 5 with the cost to be equal to 2. And 5 to 3 with the cost to be equal to, that is 6. And what is the total cost? 5 plus 2, 7 plus 6, that is equal to 13. Compare with the previous value of the distance of 3. So previous value is equal to 14 and the updated value is equal to 13. So you have to take the minimum, that is 13. And that is the purpose where distance of 3 is being updated with the new value, that is 13. So you should not take this because already we have taken into the solution set, and this should not be taken because we have already taken this kind of the value. So what is the minimum between the other values? The other values that are being present. So the other values that are being present within this kind of the solutions iterations is nothing but that is 2, because already we have taken we have considered vertex 4, vertex 5, and between these two, what is the minimum? That is minimum is equal to 8, and you have to choose that kind of the vertex into the vertex selected column. So in your next iteration, that is 1, 4, 5, and the vertex that you have selected, that is 2, and the same process continues. What does this mean? That is from, you cannot take 1 because already cost of 1, distance of 1 will be equal to 0, and this should not be taken, this should not be taken. And whereas here in this case, since you have already considered the distance of 2, the next thing, that is 1 to 4 to 5 to 2, can we reach to 3? That is what your third iteration indicates. So 1 to 4 with the cost to be equal to 2, and 4 to 5 with the cost to be equal to 2, and 5 to 2 with the cost to be equal to 3, and 2 to 1 with the cost to be equal to 1. What is the total cost? 5, 6, 7 plus 3, 10, 11. And here one correction. Where did I miss out? Okay, 1 to 4, 5, and 4 to 2. Because 4 to 2, there is also an edge that has been associated from 4 to 2. So 1 to 4 to 2, that is with the cost to be equal to 3. And from 2, we can reach to 3 with the cost to be equal to 1. So 5 plus 3, 8 plus 1, that will be equal to 9. That is what the new value has been updated. So when you consider about the previous value, distance of 3 is equal to 13. Now after taking this kind of the solution, that is distance of 3 is been updated with the value to be equal to 9. And that is how the new values are being updated into the solution. And this process goes on for your next iteration. That is 7 will be the minimum. That is only vertex which is to be taken into the consideration of the vertex selected. So in your next iteration, 1, 4, 5, 2, and the vertex that has been selected is equal to 3. And that is how, since we have explored all the kinds of the vertices, you get the solution set, that is 1, 4, 5, 2, and similarly 3. Now this has been left as an exercise for you, and you can also find the solution, that is 1 to 4 with the cost the shortest distance to be equal to 10, 1, 4, and similarly 5 with the shortest distance to be equal to 25, 1, 4, 5, 2 with the distance to be equal to 45, 1, 3 with the distance to be equal to 45. We cannot reach to 6 because when you have taken the source vertex to be equal to 1, there is no way of reaching to this kind of the vertex, that is 6. So this is how this video ends, and in your next video I'll be covering about the dynamic programming.